In this video, we're going to graph absolute value functions and then also write an absolute value function when given a graph. So the absolute value function, the base format would be written as f of x equals, we have our a times the absolute value of x minus h plus k. Now our h and k is our vertex. So our vertex here, because it says x plus 4, I know that it's going to go to the left 4 because it's really x minus a negative 4. So it's going to go 4 to the left, up 1. So normally it's at 0, 0. So if I go 4 to the left, up 1, the vertex is going to be right here at negative 4, 1. And then I can use the slope, or a, to determine the other points. So I can go down 2 to the right 1, or I can go down 2 to the left 1. That's one way of determining that and drawing our graph there. Or we could put numbers in for x. So if I put in, so think of like I have the axis of symmetry that goes through the vertex here. If I put a negative 3 in for x, negative 3 plus 4 is 1. Absolute value of 1 is 1. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. And then I can mirror that point. So my graph will look like this. So there would be my absolute value function. Now this other example, we're given the function, given the graph of the function, we need to write down what is the actual function. And in this particular one, we're going to do the transformed function. The blue graph here is the parent function. So we're going to see how did it go from the blue to the purple. Now the first thing I want to do is identify my vertex. So I'm going to have g of x equaling absolute value, and this would be x. My vertex is now right here, and I would consider that negative 3, so 0, negative 3. So I would say plus 0, and it went down 3. And we need to know what is our a going to be. And in order to find our a, we're going to choose a point that we know the coordinates of. And so if I look carefully at the graph here, I don't have an exact point that I know what the coordinates would be on here. So I'm going to pick one. Since my coordinates are counting by 2's, I know the halfway point would be like the odd numbers. So if I choose this point right here, that point right there would be negative 2 and negative 5. So I'm going to substitute that coordinate in for x and y. So when y is negative 5, I need to find a when x is a negative 2. And now I can solve for a here. So I'm going to add 3 to both sides. And I get negative 2 is equal to, the absolute value of negative 2 is 2. 2 times a is 2a. Then divide by 2. I'm going to have a equaling a negative 1. If a is a negative 1, the function would be g of x equaling negative 1 times absolute value of x minus 3. And if I look carefully at this one, I could plot another point. Let's just say I chose 2 and negative 5. So if I put a 2 in for x, the absolute value of 2 is 2. 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. So I know that this would be my function. And the reason why this is going to be a negative here is because if you notice from the parent function, it reflected over the x-axis, which means it's affecting our y's, which is on the outside of our brackets. So that's how you can graph an absolute value function and then write an absolute function when given a graph.